Another trick of the trade involving exponential equations. If we can write an exponential equation into the form au squared plus bu plus c equals 0, it is a quadratic in form. And we may use what we call a u substitution to solve. So let's just jump right to an example. Example 8, e to the 2x plus 9e to the x minus 22 equals 0. Let's solve that. So first note to solve, e to the 2x is just e to the x squared. So we do have an equation that is quadratic in form. We first have to identify what is u. That's going to be our substitution statement. So let u equal e to the x. And therefore, u squared equals e to the 2x. Now we can rewrite the equation in x in terms of u, and it will simply be u squared plus 9u minus 22 equals 0. So we just rewrote the equation in quadratic form in terms of u. Now we'll be able to factor these with any of our factoring techniques, and in this particular case we're looking for factors of negative 22 that add up to 9. So I quickly recognize I have u minus 11, u plus 11 because I want a positive 9, times u minus 2. Positive 11 times negative 2 gives me negative 22, and positive 11 minus 2 gives me positive 9. So the zero product property says one of these factors is 0. Solving for u, we get u either equals negative 11 or positive 2. So we've solved the quadratic equation in terms of u. Well, we want to solve the original equation in terms of x. So now we're going to back substitute or reverse substitute. What was u? It was e to the x. So we have two equations to solve still, but we want to solve for x. So let's take the ln of both sides. Well, what happens when we try to take the ln of negative 11? We can't. We can't take the natural log of a negative number. We can't take the log of any base of a negative number. So this is not going to be a solution. But when we take the natural log of both sides of e to the x equals 2, well, the ln of e to the x is just x, and ln of 2 is some exact number, and that is the solution. So I already said it, but let's write it here. Remember, we can't take the log of a negative number. So the exact answer is ln of 2, which is approximately equal to 0.6931.